Welcome to the Rim Break Rodeo. We hope this video helps.
You start by collecting only the essentials, the supply frequency in HZ and the motor's pole count. Write them down now. Once done, convert poles into pole pairs by dividing by 2 because the formula uses poles directly. Then apply the core formula. Synchronous RPM equals 120 times frequency divided by number of poles. This gives the theoretical no-load speed. Make sure to keep units in HZ and poles to avoid conversion errors, and don't round until the final step. Next, you account for slip because real induction motors run slower than synchronous speed. Find slip from the nameplate or typical values for the motor's load. Low-load motors may have 1-3% slip, heavy-load motors 3-8% or more. Once you have slip as a decimal, compute actual RPM equals synchronous RPM times 1 minus slip. For accuracy, measure the shaft with a tachometer and compare. This confirms assumptions and reveals if slip changes under different loads, so you can refine calculations. Finally, present the RPM rounded to a useful precision and document your inputs: frequency, poles, slip value, and measurement method. If your measured RPM differs significantly from the calculated value, more than about 5%, stop and check supply frequency, incorrect pole count, or motor wiring errors. Also confirm your tachometer calibration. If slip varies with load, rerun the calculation using measured slip under the actual operating condition, and then remeasure to confirm the corrected RPM.
Thanks for watching. Consider subscribing if we helped you.